when you're doing the formulas, would it be better if you just did the multiplication? Like if you put the sign of multiplication so it doesn't get messy?
Put the sign of
Like
multiplication.
if you put like cosine beta type.
Oh, little dots between them? If it makes you feel better. Like if it makes it easier for you. Like if it makes it easier for you, then is that what you mean? Put dots there? Yeah, sure. It's implied multiplication, so if you need it there, go ahead. I mean, there's other things we're not putting here that technically are here, right? Like this alpha is the argument of that cosine function. This beta is the argument of that. This right here is in there. This right here is in there, right? Like we can't put these alphas together out here as an alpha squared. We can't put the betas together as a beta squared. They're trapped inside the trig functions. So we're not putting parentheses. We could. We don't have to. It's implied. Same with the multiplication. It's implied. Does anyone see the next step?
Can we just separate the two so it's cosine over alpha, cosine alpha and cosine beta over cosine alpha and cosine beta minus the other one?
So you're using a property of fractions that we all need to be comfortable with. If you take something like 3 plus 4 and you put that over 5, we should all be comfortable with the fact that that's 3/5 plus 4/5, right? If you have two terms in the numerator and one term in the denominator, you're allowed to split it up, aren't you? Does it work the other way around? If you have 5 over 3 plus 4, can you split that into 5 over 3 plus 5 over 4? Does it work that way?
No.
No. That's not okay. This is okay, right? I mean, think about it, right? If you started here, could you put these together? Yes, they have the same denominator, right? They have the same denominator, so you just put them together and it becomes that. Or if you start here, you can split it apart. That doesn't work here, right? Can't put those together. They don't have the same denominator. So this doesn't work. All right, so what's being suggested here is since we have two things on top, right? And we have a single thing on the bottom, let's split it in two fractions. And if you do that, do y'all see it? You're there now? Cosine alpha, cosine beta over cosine alpha, cosine beta minus sine alpha, sine beta over the cosine alpha, cosine beta. This is a 1, right? That's itself over itself. Same thing over itself. Minus, and then this is tangent alpha, tangent beta. And that's what we were trying to get to, right? These are easy. I'd admit that. Compared to the ones we've been doing, like the other ones for homework, these are a lot easier. All right, we're getting there. We got 30 minutes left. We still got a lot to do.
Yeah, we got 2 more questions.
All right. Good? All right, I've been asked about a homework problem, and this is, actually you're the third person now to ask about this, so I think everybody's having kind of the same issue with this. It was secant?
Secant of negative pi over 12.
Secant of negative pi over 12. You're supposed to do this without your calculator.
Wasn't this one of the homework?
Yes, this is a homework problem, right?
I hated this one.
Yeah, okay.
This one's stupid.
So, first things first. Do we all agree that this is 1 over cosine of negative pi over 12? Do we all agree with that? It's the reciprocal of, that is the reciprocal, right, of this. Take that, flip it over, that's, okay. So what we need to do is see if there's any way that we can break down negative pi over 12 into being the sum or difference of two angles we do know. See, because we have this formula from last class that allows us to figure out what cosine of alpha plus beta is. We have a formula for cosine of alpha minus beta, right? If we ever see something like this, we have a formula for it. So the hope here is that somehow alpha plus beta is equal to negative pi over 12, or alpha minus beta is negative pi over 12. So you have to come up with two angles that either add up to be this or subtract to be this. And the two angles you find better be angles you know about on the unit circle. Yes?
I was gonna answer.
Yeah, tell me. What did you come up with?
Pi over 4 minus pi over 6.
Pi over 4 minus pi over 6. How did you get that?
What I did was I did pi over 12 and I tried to equal it, like tried to split it up into 2 no.
Okay.
Then I
So was it more like a guess and check type thing? Okay, so it was kind of a guessing check thing. That's one way to approach it, right? Another way to approach it would be, okay, so let me ask you this. Do you think that it's going to be two angles added together to get a negative, or do you think it's going to be two angles subtracted to get a negative?
Subtract.
Probably this, right? So let me write this down. We want to see if we can get two angles, alpha minus beta, if we can get those to be equal to negative pi over 12. Can we figure this out? And we want one of these to be an angle we know. So we're gonna guess. We're gonna guess. What did you use? Pi over what?
Pi over 4.
Pi over 4? Okay. So let's just guess first pi over 4. Now this is kind of a guess. The only thing that tips us off is the fact that this denominator has a 12 in it, and the factors of 12 are, well, 2, 3, 6, right? 4. So there's a bunch of different numbers, which is why pi over 3, pi over 6, pi over 4, those are all like our common angles. There's a reason this is a 12 and not a 13. If they put 13 here, we're done. We're done. We can't do the problem. So we're going to guess, right? We're going to guess pi over 4 minus some angle beta is equal to negative pi over 12. And now to find beta, what do I need to do?
You're gonna have to multiply pi over 4 by 3.
Multiply what?
Multiply pi over 4.
Multiply by the reciprocal.
Oh, well, this is being subtracted.
Well, you can make the pi over 4 3 pi over 12 and then subtract it over.
Yeah.
Right?
Okay, all right. Let's isolate beta. How about that? Let's try and get beta by itself. Yes? How you do that is up to you. Some of you are going to move this to the other side and subtract it, right?
Yeah.
That's not what I'm going to do, just because that's not the way my brain works. What I'm going to do is I'm going to move the beta to the other side, which makes it positive, right? I'm going to move the negative pi over 12 to the left, which makes it positive over here, right? So I'm going to rewrite this as pi over 4 plus pi over 12 equals beta. And I'm hoping, right? Hey, I'm hoping that when I put these together, it's an angle I know. That's what I'm hoping for. So I would have to get a common denominator here. So I have to multiply the top and the bottom of this by 3, right? Just that first fraction. And we get 3 pi over 12 plus pi over 12 equals beta. And what is that when you put those together?
It's 4 pi over 12.
4 pi over 12. And that's what beta is, right?
But simplify it would be
Reduce it, right? Reduce that. Pi over 3 is beta. So look, it works, right? If you want to know if pi over 4 minus an angle equals negative pi over 12, then this will work if you let beta be pi over 3. And guess what? Pi over 3 is one of our common angles as well. So here's what we have. Negative pi over 12 can be rewritten as pi over 4 minus pi over 3. Does that help at all? I mean, there's different ways you could get to this. But am I addressing the initial question here?
I tried taking like a completely different route.
Were you able to get to it though?
No.
Yeah?
So I converted pi over 12 to negative 15 degrees, and then my alpha was 30 degrees.
That's an approximation though. Right? As soon as you,
So 180 divided by 12 is 15.
oh, it's a perfect, okay, so it goes in there perfectly.
Yeah.
All right,
So, and then I tried to do 30 degrees for my alpha and 45 degrees for my beta.
okay.
But I don't know what I was doing after that, because I erased it.
That would work because this is 30 degrees. Right, sorry, this is what? We have 45 and 60. So we're doing 45 minus 60, right?
Okay.
which is this. What did you say this converted to?
Negative 15.
Negative 15 degrees. So if you take 45 and you subtract 60, you get negative 15 degrees.
Okay.
So you're doing the same thing. You just convert everything to degrees first. All right, so now once you have this, you go to this formula right here. You replace alpha with pi over 4, place beta with pi over 3, and then use your formula. Okay? I'm not going to go through that part. You get that answer, whatever it is, and don't forget, you have to do the reciprocal. So whatever answer you get through that, flip it over, flip the fraction over, and you'll get secant. Okay, I have another question for you. The likelihood of me asking you a question like that on a test is about almost nothing. I don't find that as a very useful problem. All right? I don't. It's not. I mean, the ones we've been doing up to this point today have been good problems for tests. This is not. This is just an exercise in can you figure out two angles that add up. And there's only so many combinations you could ever have, right? You could either have, pi over 3, pi over 6, pi over 4. And yeah, it's just not, to me, it's not a very worthwhile problem. This, however, is. I would like for us to find the exact value. So find the exact value of cosine, I'm just going to write it the way the book writes it, bracket of tangent inverse of 5 over 12 minus sine inverse, not sure why they put this one in parentheses, minus or negative 3/5. That's the way they wrote it. I want the exact value of this. What is cosine of arc tangent of 5/12 minus arc sine of negative 3/5? That looks horrible, right? So let's remember something about inverse functions, right? Inverse trig functions. The whole idea is that when we were looking at domains and ranges, if we have a trig function, right? Trig functions, they take angles, right? Theta, let's say, and they spit out a number, right? So if you do like sine of an angle, it spits out some number. Cosine spits out a number. That's what trig functions do. When you go backwards, the inverse ones, right? The inverse trig take numbers back to angles, right? I showed you all this several times now. So would you all agree that whatever this is, whatever it is, it's an angle? Right? This answer right here, just this, that's an angle. So would you all agree I could call it, I don't know, alpha? Some angle, I don't know, right? This, on the other hand, is another inverse trig function that would return an angle to me as well, right? Not necessarily the same angle, but an angle, yeah? So let's call this beta. So if you squint your eyes just right, do you all see we have cosine of alpha minus beta? Cosine of alpha minus beta. Okay, so we have a formula for this. The formula says this will be cosine of, let's not write it in there yet, but it's cosine alpha, right? What would it be? Cosine alpha, cosine beta, right? And then plus sine alpha sine beta, right? Cosine alpha beta alpha beta. Do y'all see what I'm doing? You have to kind of take a step back, slap yourself a few times, and you can see that. Yes? Cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. But what's alpha? This, right? So that's going to go here. And then beta's going to go there. And okay, so I'm going to write that down. It sucks, but tangent inverse of 5/12, right? And then this right here is sine inverse of -3/5. And then this is tangent inverse of 5/12. And then sine inverse of -3/5. That first step is just us applying the difference formula for cosine to this expression, right? Questions? All right. Now, we got to figure out what this is. All right? We're not done, all right? Not by any means. So what I'd like to do now is this. I'm going to write something down here. See that right there? I'm going to write it down. Alpha is the inverse tangent of 5/12, right? That's what it is? That's what alpha is? But doesn't this mean that tangent of the alpha must be 5/12? This goes back to when we were studying inverse trig functions. To say that this angle is the inverse tangent of 5/12 means that if you take tangent of that angle, you should get 5/12. Yeah? Now, I want to draw this angle. I want to draw it for you. What quadrant am I in? What quadrant can I not be in? I should say it that way. Second and... Well, let's do this first. That inverse tangent is only defined when? When you're in which quadrants? What's the domain restrictions on arctangent? -π/2, π/2, right? -π/2 to π/2 is the domain restriction for this. So that automatically is telling me that I'm not over here, right? Do y'all agree? We can't even talk about inverse tangent unless you cut off the second and third quadrants. Yes or no? Yes. Then, on top of that, this is a positive number. Tangent is turning out to be a positive number. So which quadrant would I have to be in then? The first, right? I couldn't be down here because then tangent would be negative. So I'm going to eliminate. So by a process of elimination here, I know I'm in the first quadrant. Can't be over here because the arctangent isn't defined over there. And then I have to be in the first because, well, tangent can only be positive in the first quadrant. Which means I can draw this point over here. And do you know the x and y coordinate? What is it? What is it? 12's the x coordinate and 5 is the y coordinate, right? Okay. Now I really kind of need you to kind of back up for a second and understand why the hell I'm doing this. Look at that expression again. We really want to know what cosine of alpha is, right? I mean, like, forget how complicated that shit looks, right? At the end of the day, I need to know what cosine of alpha is, right? For this one, cosine of alpha. Well, if I have the whole picture over here of alpha, then can you figure out what cosine of alpha is? If you have the x and the y, can you get the r? Then can you tell me what cosine of alpha is? Yes, and then you can just tell me what all this is, right? All of that together, you can tell me what it is. And then over here, I'm going to need to know what cosine of beta is, right? So I'm going to need a picture for beta. I should put here that this is alpha just for clarification. This is alpha based on this picture. Let's finish this off over here. I know that x squared plus y squared is r squared. So 12 squared, 144, plus 5 squared is 25, must be r squared. What's that?
169.
That's a perfect square, isn't it? I believe. What is it? 13. So plus or minus, right? But it's the radius, so it'll be 13. So we know not only in terms of alpha, right? In terms of alpha, we know what x is, we know what y is, and we know what r is, don't we? X, y, and r. So can you tell me now, right now, can you tell me what this is? Cosine of alpha. 12 over 13. X over r, right? 12 over 13. So this is 12 divided by 13. Is there anywhere else where I have alpha up here?
5.
Over there, right? You can tell me what this is now. Because again, if you squint your eyes, that's just sine of alpha, right? Sine of alpha, according to this, would be 5 over 13. So I know what this is. What's left now for me? I need to figure out what's going on with beta, right? I need to figure out what's going on with beta. So I'm going to play the same game, and I'm going to draw another picture. Here's what I know about beta. I know that beta is equal to sine inverse. Well, I'm kind of getting in my own way over here. Can I erase this yet or no? Can I get rid of this? Yeah? All right, so now I'm going to go work on beta. I know that beta is the angle that I get when I take inverse sine of negative 3 over 5. Right? Let's talk about domain restrictions. What's the domain restriction for arc sine? That's cosine. First and fourth, same as tangent, almost the same. Tangent doesn't include pi over 2, negative pi over 2. Like inverse tangent, you can't have the actual top point and bottom, but for inverse sine you can. It's no big deal. I mean, we know it's not these, right? It's not there. And we also know a little bit more because if, I forgot to write this down, oops. This means that sine of beta is what? To say beta is sine inverse of negative 3/5 means sine of beta is negative 3/5, right? So that forces us into what quadrant? Fourth, right? Because sine is the y coordinate. So we know we're not over here because of that, because it's negative. And so we've got this angle over here, right? Beta. And we got this point. And what do we know about that point? Sine is what over what again? Y over r. So what's y for us? Negative 3, right? And you have to pick up the negative because we dropped down, right? So this is negative 3. We don't know x yet, but we do know r is 5, right? So we know r is 5 here. I hope that this is all starting to like make sense together. I hope. And now, once I know what that is, right, I should be able to figure out what cosine is and tangent and all that, right? What do we need, though? We need cosine beta, right, which I should be able to get, right? I'm just going to need that x coordinate. Do we know what sine beta is? Yeah, we actually know that right now, don't we? We don't even have to do any work. We know what it is, but I need cosine beta. So I'm going to use this information. Use Pythagorean, x squared plus y squared is r squared. X, we don't know, x squared plus the y coordinate is negative 3 squared equals 5 squared. And 25, take away 9, 16. You're going to get x is plus or minus 4. Plus, because you're in the fourth quadrant, right? So x is 4. So I know that this is 4. 4, negative 3. All right, so let's fill those pieces in and we'll be done with this. This right here is what? 4 over the r, which is 5. Good. And remember, these are being multiplied, right? Plus, and then we have 5 over 13. And then here, this one is negative 3 over 5. So negative 3 over 5. And then that equals, let's go ahead and do this, multiply across, 48 over 65? I can't do arithmetic. Plus, minus actually. It'll be minus because this is going to be a negative number, right? Negative 15. So I'm going to put minus and then I'm going to put 15 over 65. And 48 take away 15, 33 over 65. 33/65. I love those problems. If my student can do that problem, they show me they understand a lot of things, right? They understand how to use a sum difference formula. They understand how to take a step back and see that really, even though this looks complicated as shit, it's really just cosine alpha, cosine beta, sine alpha, sine beta. Then they understand how to convert an inverse expression into a regular expression, how that has a domain restriction, how to determine with the signs what quadrant you're in, and then how to use the Pythagorean to recover the information to get, you see? I mean, it's a lot of things you have to keep in order for this, right? So if a student can do this successfully, I think they've demonstrated they get it. Yes? All right, so in your homework, if you came in later, you didn't hear me, the homework for this section, we're still in 8.5. I gave a couple of problems at the end of class to be done out of the ebook, right? Remember Jared came up and wrote them down? Still, those are great. Do those problems. But you also should do now the homework online through the Pearson website for this section. All right? And so what I did today is I kind of just like thumbed through that homework assignment and made sure that you can handle everything that's in here. So everything should be doable for you. It's not due until next Tuesday before our exam, which is a week from today. There's only one problem like this in the homework. If you want to do additional problems, just go to the ebook and look them up. There's a section here, at least in this textbook that I have, looks like problems 73 through 84 are all problems like this. I promise you something like this on the test. Promise? Promise? Yes. We have not started 8.6. Yeah, so we are officially one day behind. So we were supposed to do 8.6 today. We will do 8.6 next class, and then that should be what will be on the test. All right? So be here next time for 8.6. Have a great day, right? Or is it time, right? Yeah, I don't have enough time to do anything else. All right, good? All right, have a good day. If you have any questions, I'll hang out for a little bit.
And then they kept delaying it, and I was like, no, it's